Hello, 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 hello. So in this lesson, we're going to determine whether compounds are neutral, acidic, or basic. So the question is, determine whether the compounds below are acidic, basic, or neutral. Okay, so we are looking at general ideas on how to determine whether they are basic, acidic, or neutral. So the first one is sodium nitrate. So is sodium nitrate acidic, basic, or neutral? The way to tell is to ask yourself what two molecules will make this molecule. And in this case, sodium is usually found in sodium hydroxide. Nitrate can be found in nitric acid. I'm doing a base and an acid because base plus acid will give me salt, which happens to be that. Now, you should see that sodium hydroxide is indeed a strong base. Nitric acid is indeed a strong acid. If you have equimolar, like same molarity, same number of moles of sodium hydroxide and nitric acid, you're going to get sodium nitrate with neither of the two being excess, and therefore you will expect the solution to be neutral. In other words, when equimolar amount of strong acid and strong base react, what you get is a neutral solution if they are indeed equimolar. So sodium nitrate is neutral. Okay. Similar approach will be used to determine if ethyl acetate is acidic, basic, or neutral. So again, I will decompose the salt to their source. I'll decompose the salt to its source. And in this case, I know that the acetate most likely came from acetic acid. Acetic acid must be a weak acid. It does not completely ionize in water to give you lots of H+. So this is weak acid. Okay. Sodium, on the other hand, is coming from the sodium ion would come from, let me look for my pen here. Lost my pen. Okay, so the sodium ion would come from sodium hydroxide again, because we are looking at reaction of acids and bases to give us salt. Sodium hydroxide is indeed a strong base because when it breaks down in water, like I explained in yesterday's lesson, it gives you a lot of OH minus. So you have a weak acid and you have a strong base. So obviously you know who's gonna win here. The base will win because it's strong. So in other words, when you have weak acid added to a strong base in equimolar amounts, you're gonna result with a basic solution. So this salt right here is basic. Okay, that was the second example. The third example to determine if it's acidic, basic, or neutral is HCl. Now, this is a very common acid. It's even found in your gastric system, in your stomach. It's a strong acid. pKa is very low. pH does not tell you acidity. pKa does. The pKa is very low for HCl. It's a strong acid. So this, we know it's a strong acid. How do we know that? When you put HCl in water, okay, let me say plus H2O, you will get H3O plus Cl minus. You see, I'm using a complete arrow instead of using an equilibrium because it completely ionizes to give you these two products. So it's a strong acid. So I would expect this one to be acidic. That's just common sense. Not much to explain about that. Again, the pKa is very low. Like I said, it completely ionizes in water. So it's indeed a strong acid. So the other example that we need to determine if it's acidic, basic, or neutral is ammonium chloride. Again, to determine this, you have to break or decompose the molecule like we've been doing. So you have NH4 plus and you have Cl minus to give you this salt. Okay. Where does NH4 plus come from? It comes from ammonia gaining a proton. Focus on ammonia. Ammonia in itself is a weak base, which means NH4 plus is gonna be a weak acid, although some chemists are arguing that NH4 plus is a strong acid. For me, I know it's a weak acid. It's a Bronsted acid, like I explained in yesterday's lecture. So that was for NH4 part. Cl minus came from HCl. You see how I put H plus here? Probably that could have been the source. This is a strong acid. Now you have strong acid. Okay, actually this came from a strong acid. Okay, let me get you corrected here. This Cl minus came from a strong acid. NH4 plus came from a weak base. So the combination we have here is strong acid plus weak base that made the NH4Cl, the ammonium chloride. So obviously the strong acid will win over the weak base. This wins over the weak base. So this solution is acidic. Like I said, some chemists argue it's a strong acid. Some argue it's a weak acid. For me, I would say the solution should be weakly acidic. Weakly acidic because ammonia does not completely ionize in water to give H plus. This thing here, ammonium, it does not completely ionize to give you proton in water. So I would take it to be weakly acidic. So the salt here is weakly acidic. All right. So we have more examples to do to determine whether they're acidic, basic, or neutral. Again, to determine that, we have to use or determine what made those salts. So the other one is sodium chloride. So the question is sodium chloride acidic, basic, or neutral? Again, we have to decompose the structure. It's made of Na plus and Cl minus. So what is the source of Na plus in this case to make this salt? Remember, like I said, acid plus base gives you salt. It gives you salt, right? It could be salt plus water or salt plus CO2 plus water, but I'm just focusing on the salts right now. That's what we are asking ourselves, whether those salts are basic, neutral, acidic. So the source of Na plus happens to be sodium hydroxide, which is the base. The source of Cl minus can be HCl. Okay, so what do we know about sodium hydroxide? Sodium hydroxide is indeed a strong base. What do we know about HCl? HCl is strong acid. So what happens to the overall solution? The overall solution, if you have equal amount or equal moles of sodium hydroxide and HCl, they will neutralize each other. So the solution is indeed neutral. The solution will be neutral. Okay. All right. Amount of equal moles of sodium. So next, we are going to check whether this molecule here is neutral, acidic, or basic. This compound here is potassium nitrite. The name is potassium nitrite. Is potassium nitrite acidic? Is it basic? Or is it neutral? Okay, so to do that, we decompose the compound again. That's K plus, and then this is NO2 minus. So what is the source of K plus that would have made potassium nitrite? The source could have been KOH. That definitely is a strong base. And then what is the source that brought the nitrite? It must be HNO2. Remember, HNO2 is different from HNO3. This is a strong acid. This is a weak acid. So this is weak acid. Okay, so when you have a strong base added to a weak acid, who wins? Obviously, the base is stronger, so the solution will be basic. So this salt right here is indeed basic. Okay, why? When you have weak acid, Wa plus Sb, strong base Sb, will always give you basic solution or salt, and that's what we have on there. So you must be now comfortable to determine whether a given salt is acidic, basic, or neutral, whichever compound you'll be given, whichever inorganic compound you'll be given. See you soon for some organic chemistry lesson.